The National Electrical Code does not explicitly cover the sizing of gutters for conductors larger than number 4 American wire gauge. However, it does provide guidance in Article 314.71, which covers splices in enclosures. Based on the National Electrical Code and industry practices, it is reasonable to apply the requirements of Article 314.71 to gutters that contain splices for large conductors. This means that the gutter must be sized to provide adequate space for the splices and the associated terminals, while also allowing for proper bending and wire routing. When sizing a gutter for large conductors, consider the following factors. Firstly, conductor size and quantity. Determine the total cross-sectional area of the conductors being spliced. This area will determine the minimum size of the gutter. Secondly, terminal block type. Terminal blocks for large conductors can vary in size. Consult the manufacturer's specifications for the specific terminal blocks being used. Thirdly, bending radius. The conductors must be bent to fit within the gutter. Ensure that the gutter is large enough to provide an adequate bending radius for the conductors. Fourthly, splice layout. The splices must be arranged in a way that minimizes interference and provides access for maintenance. It is reasonable to consider the gutter as a junction box for the purpose of sizing. By considering the gutter as an enclosure for splices, the requirements of Article 314.71 can be applied to ensure adequate space and accessibility for the splices and connections. Based on the above considerations, it is reasonable to conclude that an 8-inch wide gutter may not be sufficient for pulling two parallel sets of 3/0 phase conductors and making a 90-degree bend into it. A larger gutter size may be required to provide adequate space for the splices and proper wire routing. It is advisable to consult with the local authority having jurisdiction for specific guidance on this matter, as they may have additional requirements or interpretations. When working with electrical installations, safety and compliance with the National Electrical Code are paramount. Understanding how to properly size gutters for large conductors ensures that the installation is safe, accessible, and meets the required standards. This involves considering various factors and potentially consulting with local authorities to ensure compliance. Let's delve into the details of sizing gutters for large conductors, referencing the National Electrical Code where applicable and highlighting the key considerations. While the National Electrical Code doesn't explicitly detail the sizing of gutters for conductors larger than number 4 American wire gauge, Article 314.71 provides essential guidance on splices in enclosures. This article becomes a crucial reference point when determining the appropriate size for gutters housing splices of large conductors. The rationale is that a gutter, when used for splicing, effectively functions as an enclosure. Therefore, applying the principles of Article 314.71 ensures that the gutter provides sufficient space for the splices, terminals, proper bending, and wire routing. Several critical factors need careful consideration during the sizing process. Firstly, conductor size and quantity. The total cross-sectional area of all conductors being spliced within the gutter is a primary determinant of the minimum gutter size. Larger conductors necessitate more space, and the cumulative area becomes a baseline for sizing. Secondly, terminal block type is also crucial. Terminal blocks designed for large conductors come in various shapes and sizes. The manufacturer's specifications for the specific terminal blocks being used must be consulted to determine their space requirement. Thirdly, the bending radius of the conductors. Large conductors require a larger bending radius to prevent damage to the conductor insulation and ensure long-term reliability. The gutter must be large enough to accommodate this bending radius without putting undue stress on the conductors. Fourthly, the layout of the splices. The arrangement of splices within the gutter influences the overall space needed. A well-organized layout minimizes interference and ensures that each splice is accessible for future maintenance or inspection. The concept of treating a gutter as a junction box or enclosure is a valid approach for sizing purposes. By doing so, you can apply the requirements outlined in Article 314.71, which addresses the space and accessibility needs for splices and connections within enclosures. This approach aligns with the intent of the National Electrical Code to ensure safe and functional electrical installations. An 8-inch wide gutter may not be adequate for the described scenario of pulling two parallel sets of 3/0 three-phase conductors and making a 90-degree bend into it. The combination of conductor size, quantity, bending radius, and splice arrangement is likely to demand more space. A larger gutter may be necessary to accommodate these factors safely and effectively. Given the complexities involved and the potential for varying interpretations, consulting with the local authority having jurisdiction is always recommended. The authority having jurisdiction can provide specific guidance based on local codes, regulations, and accepted practices. Their input can help ensure that the installation meets all requirements and avoids potential issues during inspections. When sizing gutters for large conductors, firstly, determining the total cross-sectional area of the conductors involved is paramount. This area dictates the minimum size the gutter should be to accommodate all conductors comfortably. Secondly, considering the terminal blocks being used is also vital. Different types and sizes of terminal blocks will require varying amounts of space within the gutter. Thirdly, the bending radius of the conductors must be taken into account. Insufficient bending radius can damage the conductors and compromise their integrity. Fourthly, the layout of the splices within the gutter should optimize space and accessibility. A well-organized layout ensures easy maintenance and inspection. While the National Electrical Code does not explicitly address gutter sizing for conductors larger than number 4 American wire gauge, the principles outlined in Article 314.71, which pertains to splices and enclosures, can be applied. This is because a gutter, when used for splicing, essentially functions as an enclosure. Therefore, adhering to the requirements of Article 314.71 ensures that the gutter provides adequate space for splices, terminals, proper bending, and wire routing. When sizing a gutter, several key factors should be taken into account. Firstly, conductor size and quantity. The cumulative cross-sectional area of all conductors being spliced is a fundamental factor in determining the required gutter size. Larger conductors necessitate more space, and the overall area serves as a baseline for sizing. Secondly, terminal block type is an important consideration. Terminal blocks designed for large conductors come in various shapes and sizes. The manufacturer's specifications for the specific terminal blocks being used must be consulted to determine a space requirement. Thirdly, the bending radius of the conductors must be carefully considered. Large conductors require a larger bending radius to prevent damage to the conductor insulation and ensure long-term reliability. The gutter must be large enough to accommodate this bending radius without subjecting the conductors to undue stress. Fourthly, the layout of the splices is a factor. The arrangement of splices within the gutter can significantly impact the overall space needed. A well-organized layout minimizes interference and ensures that each splice is accessible for future maintenance or inspection. The approach of treating a gutter as a junction box or enclosure is a valid one for sizing purposes. By doing so, you can apply the requirements outlined in Article 314.71, which addresses the space and accessibility needs for splices and connections within enclosures. This approach aligns with the intent of the National Electrical Code to ensure safe and functional electrical installations. In a specific scenario, such as pulling two parallel sets of 3/0 three-phase conductors and making a 90-degree bend into an 8-inch wide gutter, the gutter may not be adequate. The combination of conductor size, quantity, bending radius, and splice arrangement is likely to demand more space. A larger gutter may be necessary to accommodate these factors safely and effectively. Given the complexities involved and the potential for varying interpretations, consulting with the local authority having jurisdiction is always recommended. The authority having jurisdiction can provide specific guidance based on local codes, regulations, and accepted practices. Their input can help ensure that the installation meets all requirements and avoids potential issues during inspections. To reiterate, when sizing gutters for large conductors, firstly, determine the total cross-sectional area of the conductors involved. This area dictates the minimum size the gutter should be to accommodate all conductors comfortably. Secondly, consider the terminal blocks being used. Different types and sizes of terminal blocks will require varying amounts of space within the gutter. Thirdly, take into account the bending radius of the conductors. Insufficient bending radius can damage the conductors and compromise their integrity. Fourthly, optimize the layout of the splices within the gutter to maximize space and accessibility. A well-organized layout ensures easy maintenance and inspection. Understanding the National Electrical Code guidelines, especially Article 314.71, and applying them judiciously is essential for ensuring safe and compliant electrical installations. The key is to consider the gutter as an enclosure for splices and size it accordingly, taking into account all relevant factors and consulting with the authority having jurisdiction when necessary. Let's explore each of these factors in greater detail and provide some practical considerations for ensuring that your gutter sizing meets the necessary requirements. Firstly, conductor size and quantity. This is often the starting point for determining the appropriate gutter size. Each conductor has a specific cross-sectional area which can be found in the National Electrical Code Chapter 9, Table 5 or from the conductor manufacturer's specifications. For conductors in parallel, you need to consider the total cross-sectional area of all parallel sets. The gutter should be large enough to accommodate all conductors without overcrowding, which can lead to overheating and insulation damage. Secondly, terminal block type. Terminal blocks provide a secure and organized way to connect conductors within the gutter. However, they also take up space. Different types of terminal blocks, such as barrier blocks, DI and rail-mounted blocks, or power distribution blocks, have different dimensions. Consult the manufacturer's specifications for the specific terminal blocks you plan to use to determine their width, height, and depth. This will help you estimate the total space required for the terminal blocks within the gutter. Thirdly, bending radius. The bending radius of a conductor is the minimum radius to which the conductor can be bent without damaging its insulation or affecting its current carrying capacity. The National Electrical Code specifies minimum bending radii for conductors in Article 312.6. These requirements are especially important for larger conductors, which are more susceptible to damage from sharp bends. When sizing the gutter, ensure that it has sufficient depth and width to accommodate the required bending radii for all conductors. You may need to use a larger gutter than initially anticipated to provide adequate bending space. Fourthly, splice layout. The way you arrange the splices within the gutter can also impact the required gutter size. A well-organized splice layout can minimize wasted space and improve accessibility. Consider using staggered splices, where the splices are offset from each other to reduce the overall width of the splice assembly. Also, ensure that there is enough space around each splice for easy access during maintenance and troubleshooting. In addition to these factors, there are a few other considerations to keep in mind. Firstly, fill percentage. The National Electrical Code specifies maximum fill percentages for enclosures in Article 314.16. While these requirements are not explicitly applicable to gutters, it is good practice to avoid overfilling the gutter. An overfilled gutter can make it difficult to access the conductors and splices, and it can also increase the risk of overheating. Aim for a fill percentage of no more than 40% to allow for adequate ventilation and access. Secondly, heat dissipation. Gutters can be subject to significant heat buildup, especially when they contain large conductors carrying high currents. Ensure that the gutter is made of a material that can effectively dissipate heat, such as aluminum or steel. Also, consider providing ventilation holes or slots in the gutter to improve airflow and reduce heat buildup. Thirdly, accessibility. The National Electrical Code requires that all electrical equipment be accessible for inspection, maintenance, and repair. When sizing the gutter, ensure that it is located in an accessible location and that there is enough space around the gutter to allow for easy access. Avoid placing the gutter behind obstructions or in confined spaces where it would be difficult to work on. In conclusion, sizing gutters for large conductors requires careful consideration of several factors, including conductor size, terminal block type, bending radius, splice layout, fill percentage, heat dissipation, and accessibility. While the National Electrical Code does not provide explicit sizing requirements for gutters, the principles outlined in Article 314.71, which covers splices in enclosures, can be applied. By considering the gutter as an enclosure for splices and sizing it accordingly, you can ensure that the installation is safe, reliable, and compliant with the National Electrical Code. Finally, it is always a good idea to consult with a qualified electrical engineer or inspector to ensure that your gutter sizing meets all applicable requirements. They can provide expert advice and guidance based on their knowledge of the National Electrical Code and local codes and regulations.